So there are two major ways in the uses of solar energy. One of the ways is to use it for heating purposes. And this could be heating of the space, like heating of the houses by proper design of the rooftops or the windows, for example, depending on the winter or the solar or the summer situations or conditions, and also with the use of solar light for water heating. So this type of heating purposes can be further divided into active heating and passive heating, which I will be explaining in the next few slides. The other main use of solar energy is for the generation of electricity or electrical power. And this is through the means of solar PV, the photovoltaics, which is very popular these days, and also by the use of what we call as concentrating solar power or CSP. And this concentrating solar power uses the heat, actually uses the heat of the sun by concentrating the light towards a specific area of the tower, so that once all the lights are going towards a specific area, it will heat up that liquid or fluid in order for it to generate heat, as well as the heat that is generated here from the fluid will be used to generate steam, and the steam will be the one to power the turbines. And so in the next few slides, we'll be going to talk about the details of each of these ways of energy generation. But on this class, our main focus will be on the generation of electricity. We'll discuss a little bit of the generation of heat using active and passive heating purposes. So solar radiation has been used for a long time already for natural heating of spaces. So if we properly design our structures and buildings, then we can also make use of the solar radiation to minimize our energy consumption based on the heating of our spaces. So as an example, it's a good example of this would be our own buildings in UTS. So in building 2, the central building, we use a lot of windows here, so light can just penetrate directly to the inside of the building, and also can trap some of the heat there. So during colder days, then we can utilize this heating, natural heating of the system based on the good design of the building. The same way, we have also similar thing in our FEIT building. So we have the roof are made of transparent glasses to utilize the natural lighting as well heating of the whole building. And so we can utilize this space heating by solar radiation based on active and passive systems. So the passive systems basically means passive. It means that there's no moving parts. It's just basically the proper designing of the houses as the structures. So if we refer to the houses, for example, we can also design the provision of the glasses in the houses, and also the roof toppings as well to have a shading of the solar radiation here, or the solar light. But we can also have some glasses at the walls instead of solid wood or bricks, for example, to provide some lighting inside the house that also potentially trap the heat inside the structures. So this is a natural heating and lighting at the same time. If we compare this to an active system means there is something that is moving there. There's something that is used as a means of heating. So in this case, it's a working fluid. So it could be an oil or water itself. So the active form of system is with the use of pumps. So there is a fluid, a working fluid that is being pumped from this side here going towards the solar collector. So the sun solar radiation will heat up this fluid inside these piping systems here. And once the fluid is the cold or the cool water or fluid will enter this solar collector, and there they heat up and they go back inside the house. And the hot water is still here, so it goes towards a heat exchanger. And this exchanger also uses another form of fluid. For example, in this case, is a radiator. So we have a room radiator here that uses, for example, an oil. So the heat exchangers will exchange heat to the oil, and the oil now will be heated up. and so it goes towards the radiator and releases the heat towards the house. So the main difference between these two is now we have a working fluid that continuously being pumped in inside the housing. So of course, if in comparison with the two, this system would be less energy intensive because there's no pump needed, but also not much efficient compared to this one because at least in this case, it's continuously is circulating. But with proper designing, we can always use a natural heating process so that we can utilize the heat from the solar radiation. Okay, so in the same way, we can also do this for solar water heating, not only for space heating, but also for solar water heating. So we have a similar mechanism for the space heating, like the active system as well as the passive system. So as I mentioned before, in active system, we use a working fluid to be heat up by the solar radiation. So here we have an active fluid here. It could be liquid like water or an antifreeze or oil that is being circulated towards the solar collector. So if cold water is being pumped towards the solar collector here, it then heats up, it travels towards the solar collector and heats up by the solar radiation, and then it goes back towards the system to heat up the fluid within the tank. So as you can see, there's an extra boiler or a backup boiler to also to heat up if you don't have any solar light, for example, or solar radiation at nighttime. So this heated water will now be used towards the tap. So as you can see, the liquid here, the cold, is just recirculating. So once it goes back towards the tank, wherein cold water is coming from the mains, is actually supplied over here. So it acts as like a heat exchanger. So it's exchanging heat and heats up the cold water. And then after heat exchanging, it goes back towards the pump, which is a colder water now, and goes back again towards the solar collector. So this process will just continuously, indefinitely, until such time that some of the fluid has to be replaced inside the pumping here. So this is the form of active solar water heating system. On the other side is the passive one. And so the passive one basically uses a natural convection in this case. So we don't use any pump system here, but we use a hot water tank that should be located above the solar collector. So you can see from this example here, this hot water tank has to be situated above this solar collector because it uses the differences in density in water. So if we have a cold water, so the blue lines is the cold water here. So normally the cold water has a higher density, specific density compared to the hot water. So it's because it's higher density, it means that it goes towards the process of by the use of the gravity force. So the cold water will just go down towards the pipe here and enters the solar collector. So once the sun is actually shining and radiating heat, this cold water now heats up. And so based on the density differences, so it means that at higher temperature, the density decreases. So it means that the water expands. So the heating of the water expands the water, and so it goes up. So it now the natural convection process, this process of differences in density, is now circulating the water. So hot water goes back towards the hot water tank, and then it is being used now for the use of hot water, and then the same way cold water comes in and then it goes towards the process. So as you can see, it's just work on gravitational force. Another type of a passive system uses a heat exchanger. So in this case, we have a specialized liquid that is being recirculated in this solar collector here. So this liquid doesn't really touch the potable or the water that is reusable. So in this case, we have an antifreeze liquid that is being recirculated towards from here towards the heat exchanger. So the cold water comes in, not the cold water, but the antifreeze liquid is being recirculated here. It's being heated up by the sun. So the sun is shining here. So once it heats up, it naturally expands and goes back towards the heating of another water system here. So cold water comes in this tank, heated by the heat exchanger, and then goes out as a hot water out. So it can be used for many purposes. So this system uses mainly a specialized liquid to just recirculate. And comparison to this one, this is mainly water that is being recirculated at the same time. So between the two systems, you can see that the active system expends more energy, but it is more efficient because this one has continuous cycles. So you have more mass flow coming in and coming out. In this system, a slower cycle, but has less energy, less energy intensive. It means it's more economical, but it's only good for a small system. If you have a really big system now, then it will be more complicated to work on with natural convection. So the height difference is important so as to prevent the backflow of the water at nighttime, for example, if it's cold already. All right. So this solar water heating system directly uses the solar light or solar radiation into um, heating up a specific liquid and also for specific uses of heating up the space. So when we talk about solar energy or solar power, what comes into mind right away? So in most cases, the most representative for solar power is the solar photovoltaic panel or cells that we see in many places around the world now. So even in Australia, we can see this at a lot of this in the rooftops of many buildings as well as on houses. And we also have a lot of solar farms that uses solar PV as a means of converting the solar light into electricity. So from the name itself, solar photovoltaic, the mechanism really relates on the photovoltaic effect, which is a process that generates voltage, the voltaic here, or electric current in a photovoltaic cell. So this is the photovoltaic cell upon exposure to solar light. So for the solar for PV, the device is made up mostly by semiconductor materials. The most common one is silicon. We have also gallium arsenide and other semiconductor materials that has the ability to convert the sunlight directly into direct current electricity. And so, of course, we need an inverter to transform that direct current into alternating current or AC. So when the solar cell, actually this light has the unit, the smallest discrete amount or quantum unit of the electromagnetic radiation is based on photons. Photons are what we say as a basic unit of light, and they're always in motion. They are massless. They don't have mass, and they travel on the speed of light, but they possess a lot of energy. And so these photons, if we look at this, for example, a parcel of light here, this small thing here that we can see is like a photon. And when this photon reaches the solar, the PV cells, it bounces off electrons. You know, the atoms, they have electrons. So the electrons are actually bounced off, leaving holes. And so the bouncing off of these electrons create the electric current that produces the electricity in the system. So how does it really work? And we see that one in the next slide.